Okay. So we're doing section 3.5, the 5th section of Unit 3. Mental math and multiplication. All right. The first topic that we're going to do mental math with is expanding more on our multiplying by 5 technique. I think we've introduced this before with our multiplication facts. Okay. So you can have either an even number or an odd number multiplying by 5. So we'll start with the even number multiplied by 5. Now what they say to do is they say take half the number and multiply that by 10. Well, okay, so that's the strategy. It sounds like a shortcut, but mental math is a lot about shortcuts. What we need to know is why this is true. So first I'll show you the example. Okay, so an even number multiplied by 5. With the multiplication facts, we learned like just 1 digit times 5. So we're going to do a couple of higher digits, multi-digits. So 2 or 3 digits times 5. So the strategy says take half of the number. So half of 14 is 7, and multiply that number by 10. So 14 times 5 is equal to 7 times 10, which is equal to 70. Okay. So does everybody follow that? Oops, I meant to write 70 under here. We're going to model a certain way I want you to do in the homework of mental math. Okay. So with that, we're going to just do our problem here. And then right here, we're going to do show steps one at a time. Show steps done in mind with one operation at a time. Okay, show each step. That's what that really means, show each step. Okay, and they do this as a series of equations. So I'll model this more as we go on. Now, this is the question, you guys understand? Here's the question. Why does this work? Okay, so we need an explanation of why this works. Take half the number, multiply by 10. So anything times 5.
Is it because 5 is half of 10?
Yes, 5 is half of 10. That has something to do with it. Any other thoughts?
Yeah, you do 5 and 5, like 5 plus 5, and then 7 plus 7. And you can do it like that, if that makes sense. So like 7 and 10. So it's half of 14, and then you double the 5.
Okay, yeah, so you guys are right. If you're taking half of something and then doubling it again in the same equation, you're not really changing the equation, right? So here is kind of a thought about maybe a proof, if you will, step by step here. With my example of 14 times 5. Okay, when you take half of 14, you're thinking about 2 times 7. So the number that I get here is 7. So 14 can be thought of as 2 times 7. So in order to get what that number is times 2, you take half of it. And then I'm going to multiply that by 5, or half of 10. Okay, thinking about 5 is half of 10. So I'm taking half, 2 times, yeah. So there's where the 10 comes from. Okay, so kind of like disregarding the halving and doubling. Since 5 is double 10 and 14 and 7 is half of 14, when I think about, okay, just take half the number and then multiply by 10, I'm ignoring the doubling and the halving, but they actually kind of cancel out because they'll multiply to 1. When I have this equation, I can group the 2 and the 1/2 together. And then have the 7 and the 10 at the end. Now, what mathematical property says I can do that? What property of arithmetic? Okay, mental math is all about using the properties to your advantage.
Is this the commutative?
Oh.
Great. So is that what you're going to say too, Camille?
No, I was going to say associative.
Okay, they are related.
Yeah, my fault.
And that you can do in any order, but technically what I've done was I've just switched the 2 and the 1/2 and the 7, right? So that just switching is commutative property. Okay, we'll use associative later, so let's see if we can spot it. Commutative property. Okay, now what happens to the 2 and the 1/2 is that they become 1 because 2 times 1/2, let me back that up a little bit. This right here is 2 times, 2 times 1/2 becomes 2 over 2, which is equal to 1. Okay, and that's where it becomes the identity. So 1 times 7 times 10 is equal to just 7 times 10. So notice that we can do 14 times 5 and make it equal to 7 times 10. Now, skipping all of the commutative property and everything, that's the trick for this mental math. And just summarizing it into take half of the number, multiply by 10. Okay? So when you do tricks or mental math with your students, they have to know why it works. Otherwise, they're going to forget or get mixed up with everything. That's what happens. That's what's happened historically, because people, like when I was going to school, maybe when some of you were going to school, they just told you how to do the algorithm and that's it. And you get all those steps mixed up. But mental math is good because it'll give you a deep look at it, the concepts, so you know why the tricks work. Okay, let's give another example here. The next example is when you have an odd number multiplied by 5. So even numbers are easy because you can divide them by 2. Any even number is divisible by 2. But if you have an odd number times 5, we'll use a modified approach. Oh, whoops, and okay. Excuse me for a second. Excuse me. Okay. So an odd number times 5. You want to change the odd number to an even number plus 1. Okay, that way we can get back to the even number idea. Okay, then we can take half of the even number. No, don't do this. Half of even number and multiply by 10. And add 5. Okay. So the summary is you change the odd number to an even number lower, so it's the even number plus 1. And then you take half of that even number, multiply by 10, and then add 5 more to it. Okay, so here's our example. We have 17 times 5. Now I'm going to try and model this with step-by-step equations, even though I'm doing it in my head. I'm taking my 17 and I'm making it into 16 plus 1. And I'm going to still keep the times 5. Now I'm going to do 16 times 5 plus 1 times 5. This right here, what property do I use to go from this line to that line? What property did I use?
Associative.
Good guess, but not quite.
Distributive.
Right, distributive, because I multiplied the times 16 plus 1 times 5. So the 5 times 16 and the 5 times the 1, that's distributive property. Okay, great. Now the distributive property really helps us in mental math as well to break up the numbers into easier pieces, okay, easier parts, easier numbers. Now the 16 times 5, I'm going to do my trick. What would it be? What was the answer of 16 times 5 if you use the times 10 trick? Half the number times 10.
Eight times 10.
Yeah, which is?
80.
Good. Okay, now the 1 times 5 became just 5. Now 16 times 5 you might not know offhand, but 8 times 10 is a lot easier to do. And they actually equal the same thing. Okay, so take a look at how I'm demonstrating my mental math that I'm doing in my head. 17 times 5, it's right here. That's my problem. If I set that equal to my first equation, my first step was to split up the 17 into 16 and 1. Okay? Then below that, I'm writing more of the equation. They have to be equal. So I do 16, I use the distributive property, 16 times 5, 1 times 5. And then I do change it to 8 times 10, like I proved it before. And then I did 80 plus 5 and then 85. So all of those steps are going one at a time down. So this is more of an algebraic type solution, but I'm still just using arithmetic. Is everybody okay on that? So it's a good setup to follow, technique to follow so that you can, because we'll do this in 2015 as well. Okay, so that's how that structure works for showing your mental math. Okay, so we have 85 there. Oops, I didn't even finish this one. Oh, I did. Yeah, it's up here. And the first one has 70 in it. Okay, now let's go ahead and have you guys try one. We'll use some more digits, make it a little bit trickier. $475 times 5. Go ahead and work that out on your papers. And when somebody has it, maybe somebody that doesn't talk a lot, please share out. We want to use this with mental math and also practice our step-by-step. And while you do that, I'm going to go ahead and take attendance. Okay, does anybody have an answer? Going to take half and multiply by 10. And add on 5, half of something. All right, so I'm going to open up to anybody who wants to talk for time's sake.
I can share.
Okay,
You just want me to walk you through how I did it.
yes, and then I will keep track on my iPad, so I'll go ahead and reshare that. Okay,
Okay, so I changed 475 to 474. And so I did 474 plus 1 in parentheses and then times 5 outside of the parentheses.
okay,
So then I did 474 times 5 plus 5 times 1.
okay, and that
And then
was
if we,
the distributive property help you do that?
yes.
Great.
And then I halved 474, which is 237.
Okay, now that one I think is a tricky halving. How did you
Yeah,
do
I
that?
divided it by 2.
Yeah, what was the mental math that you used to do that? Because you can take half of each digit, half of 4, half of 7, but then the 74, that gets tricky. So it's
Yeah.
200 something. I imagine a lot of people got to that.
I don't know if I did it necessarily right. I just wrote out like 2 divided by 237 and saw how many times it can go into 2, which
Okay,
is
so
twice.
did you do something like this? Oops.
Yes, 474. Exactly that. Yeah.
Okay. So if you get stuck, you can do that. Did anybody else, so we'll pause you, Tracy, on that. Did anybody else get half of 474 a different way?
I did, so 47. So I split it into 47 plus 5, but then I kind of changed it. And so then when I got 47, I knew that went in 23 times because 46, but it didn't go into the 7, right? So I guess I really did 46 plus 15. Or yeah.
Yeah, so you can do, we're actually going to do 474. So you can split 474 into 460 plus 14. Okay, you can split your number into any two numbers that will help you get to the division easier. Okay. So 474 is equal to 460 plus 14. And then you can divide these by 2 easier more mentally. So because you do, go ahead and continue on. We're not quite there yet. What's the answer?
You want me to continue? Is that what we're looking for?
Oh, no. Was it Sid? Were you telling us that?
Oh, yeah. And then 46 is 23, and then a 0 because
Mhm.
the 10. And then 15 is 7. And so then I just added those together to get 237.
Okay, great. This is more mental math. It's not like the multiplication part, but doing division like this is very handy. Break them up into numbers that make it easier to divide, and you can put them back together. All right, go ahead, Tracy, go ahead and continue on that with yours.
Okay, so then I got 237, and now we're going to multiply that by 10. So 237 times 10. So I just kind of looked at it as like 237 times 1 is just 237. And then we'll add a 0 into the place value. So I got 2370, so
Good.
2,370. And then we add 5. So then we have 2,375.
Okay, great. We did the multiplying by 10 last time, and so that's one of the very handy things to do this mental math. Okay, good tool. All right, excellent work. All right, so the homework also does some mental math of multiplying by 9. Okay, now 9, now see 5, multiply by 5 is easy because you double it to get to 10. Multiplying by 9 is easy because it's 10 minus 1, it's 1 less than 10. And so factoring that into your mental math isn't too much more of a cognitive step. Okay, so we want to connect this strategy, connect to 10, okay? Because multiplying by 10 is easy. I'm gonna use straightforward instead of easy. Easy, a relative word. Okay, when you have your students, you don't want to say easy or hard, because what's easy for some people is hard for others. What's easy for you might be hard for your students. Okay, so even among topics, that is true. So try to avoid easy or hard when you teach. All right, so here's the strategy, connecting it to 10. So we want to multiply 9 times 15. Okay, when we connect it to 10. Now the connection to 10 is just 10 minus 1. So I replace my 9 with 10 minus 1 times 15. What that does is that allows me to use the distributive property of multiplication over subtraction. Okay, we can distribute there from the back. You get 10 times 15 minus 1 times 15. Okay, so we're using the ability to multiply by 10 nicely in base 10 to help us. 10 times 15 is 150. 1 times 15 is 15. Here is where you have to subtract a little bit more mentally. Now we have some mental strategies for subtraction, and I just used the breaking up one. I break up my 15 into 10 and 5. So 150 minus 10 is 140. 140 minus 5. Here's, I'm going to write this in blue because it's like part of it, sort of. 150 minus 10 plus 5. Now, I split up my 15 to 10 plus 5. I'm going to subtract 10 and then subtract 5. So I'm trying to subtract both of those. And 150 minus 10 is 140. Oops. And then 140 minus 5 is 135. Okay. So that's a kind of a recall from subtraction mental math. All right. Multiplying by 9, make your 9 10 minus 1. Okay, let's have you try this one. Somebody else besides Tracy, show us their answer. 9 times 23. Okay, we want to find out what 9 times 23 is using mental math. Okay, this right here is in a side, so we don't want that. So since we've done subtraction already, you don't have to do like the blue stuff. You can just put the answer, because we're focusing on multiplication right now. Okay, we want to multiply 9 times 23. Yeah, so let's have somebody like Michaela or Meredith, Marley, Shelby, any of you all who are usually quiet, which is understandable sometimes. It's okay, but let's have you guys share some.
Okay, so I'll go.
Sorry.
I did 10 minus 1 in parentheses times 23.
Mhm.
And then I did 23 times 10 minus 23.
Good. So we're distributing, right?
Mm-hmm. So then it's 230 minus 23, which is 217.
Okay, hold on a second. You. Okay, mental math is great because it's so fast. Faster than a
Sorry.
calculator. Okay. Then what did you do after this one?
Oh, so I did, so then 230 minus
Okay.
23,
All right.
and then 217.
Okay, what do you guys think about that? Did I
For
copy
some
that
reason,
right?
I thought it was 207.
Yeah, it's 207.
Okay, so what's great is that when things like this come up in your classroom, you can have, you know, a nice debate, if you will, or conversation is probably more better word. Conversation, discussion about that, and we can use what's good about it is that you can bring up a couple of arguments and have people back up their arguments. Not in the negative sense of argument, but just like for discussion or conversation. Okay. Now, since Marley agreed right away that it was 207, why is it 207 and not 217? For
Because
Marley, or whoever has a suggestion. Yeah.
I did minus 13 instead of 23.
Great. And that's something that many people will do. So it's common to lose a 10. So sometimes if it's very important, because I will lose 10s too, I will kind of do some work on the calculator. So if it's with money, for example, like my finances, I use like Excel or some program, or try to calculate with the calculator, because I will just lose money. So, but most of the time we don't need to really need calculators. We can just do things in our head. Now that we're learning some techniques, we can just, the stakes aren't that high. So great work. Let's see, let's try another example. This one's gonna be a little bit trickier in the subtraction part. So we're gonna do 9 times 64. Okay, so using that same method, 9 times 64. Okay, so good job for Tracy and Marley. Let's have something from, let's see, something from like Lindsay.
Could I go, Professor?
Oh, we have a volunteer. Melissa, okay, go ahead.
I got 576.
Okay, so everybody concur. Yeah, it's kind of hard to see people, but there's some people that are here. You guys agree?
I got 566.
So we may have a mystery of the tens again. Let's go ahead and have Melissa present. So go ahead and tell me what you are, how you got your answer.
So I did the parentheses 10 minus 1, and then I did 64 times 10 minus 1 times 64.
Okay, great. Continue.
And then I did 640.
Which is 640.
Yes. Minus 64.
Okay.
And that's how I got 676. 576, sorry.
Okay. So tell us how you did your subtraction. Did you do that in your head?
No, I did it on the calculator.
What? Yeah. That's what we're doing today.
At least I'm honest.
No, and that's quite all right. I appreciate your honesty. All right, so who can tell me how to go from 640 to subtract 64 in their head mentally?
I can. So I broke it up into 40, 20, and 4. And I did 640 minus 40, which brings you to 600. And then I subtracted the 20, which brought me to 580. And then I subtracted the 4, which brought you to 576.
Okay, so with this one, you said you broke up the 64.
Into 40, 20, and 4.
Okay, and you broke it up into 40 and 20 instead of 30 and 30. Why'd you do the 40 and 20?
Just so I could get to 600. Just in my head, it made more sense that way.
Yeah, no, that's a great thought. So it's purposeful. I wanted you to make that explicit for the classmates. Good. So 640 subtract 40.
Yep.
Is 600. 600 subtract 20 is equal to 580. 580 subtract 4 is equal to 576.
It's a few more steps, but that's just how it made sense in my head so that I didn't get any tens places mixed up.
Now, that's okay that it's a few more steps. Okay. Hopefully, see, Ariana, did you have a question on the 566 versus 576? You got that?
No, I just mixed up a 10 and I was doing minus 74 instead of minus 64.
Yeah, so it can happen. Now, there's a few more steps, but they're actually kind of quicker than trying to do more math in your head. So it's okay that there's a few more there, but you can do several steps quickly instead of one gigantic step, maybe a little bit slower. So that's perfectly fine. All right, great work, everyone. What we also want to note and look at is a picture. Okay, so we're going to work on the pictorial level for a little bit. We want a picture of the technique that we're using. So picture of multiplying by 9 using 10 minus 1. Okay, so this technique that we've been studying, we're going to do a picture of it. Okay, so an example problem could be draw an array for 9 times 3 using 9 equals to 10 minus 1. Okay. So when we're thinking about 9 times 3, we're setting that equal to 10 minus 1 times 3. And just like we did with the mental math, we distributed the 3. So we have 10 times 3 subtract 1 times 3. Okay, this is what we're going to draw a picture of right here. Okay. When you draw a picture of subtraction, you want to show crossing out or take away. We're going to depict 10 times 3, and we're going to show crossing out 1 times 3. Okay. So for our pictures, for an array was a rectangular arrangement of objects in rows and columns. Okay, so for our array, it helps to know what the meaning of this multiplication is. So let's review it. We're just looking at 10 times 3. What does 10 times 3 mean?
10 groups of 3.
Excellent. So we have the 10 is the number of groups, and the 3 is the number in each group. Okay, so 10 groups of 3 is what we're gonna illustrate. And then the subtraction part is we're going to take away. Then we're going to cross out. I'm going to use crossing out. Cross out 1 group of 3. Okay, so that's what crossing out. That's what the 1 times 3 means. Okay. So we're going to do our picture. So 1, 2, 3. Okay, so counting these out, I'm doing little marbles or something, circles. So I have 1, 2, 3, 4, 5, 6 groups right now. Here's group number 7, group number 8, group number 9, group number 10. Okay. So right here, this is 10 groups of 3. Okay, that's like 30 total. So we want to do, according to our the equation, the numerical equation, we take our 10 groups of 3 and we subtract off one group of 3. So I'm going to cross out one group of 3 and then find the answer there. Okay, so I cross out that one group of 3 there. Okay, or 3 of those pieces. Now what do I have left? I have 27 left, right? So therefore our 10 times 3 was 30. And then our 1 times 3 was 3. And our 9 times 3, therefore, is going to be 27. Okay. Does everybody get the idea there? So let's go ahead and have you do an example with 9 times 5. Okay, you want to draw an array with 9 times 5. So I'll write the answer down and I'll scroll back up. Write the problem down. So you guys try this one. So I'm going to draw an array for 9 times 5 using the fact that 9 is equal to 10 minus 1. You're going to draw the array, you're going to calculate the answer. And so that's the previous example. And then I'm going to have somebody who hasn't shared yet guide me through this one. Let's see. So we have Rihanna. We have, let's see. And, oh, come on, go. Some people's names aren't here. See, Tracy did one. Okay, so Megan, Kenna, Lindsay, Michaela. Okay, so some of you guys who haven't shared yet. And guide me through the problem so I can fill out the class notes here.
So I separated the 9 for like the 10 minus 1 and then put that in parentheses and then times it by 5. So it's 10 times 5 minus 1 times 5.
Okay, so, okay. All right, great.
And so then you have 10 groups of 5. So I did 5 marbles in each of the 10 groups.
Yeah, so we have Weber State purple marbles because Weber State is great, 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 right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
And
Okay.
then for the 1 times 5, so you just have one group of 5 that you cross out.
Okay. Goodbye, Weber State marbles.
And so then the 10 times 5 is 50. The 1 times 5 is 5. So 9 times 5 would be 45.
Excellent. Yes, we did 10 times 5 equals 50. And our 9 times 5 is going to be 45. Now this is in math, primary math 3A. When they introduce this model to the students, they kind of do the model, they cross the things out. Well, they don't show cross out, they just show a different color. But I like crossing out because it shows that we're taking it away. And then they just do two equations down there to derive what 9 times 5 was. Okay, excellent work. What they're also going to do is take a look at the 9s multiplying by 9 again using or a pattern finding. Okay, so pattern finding is also a fun thing to do. So essentially the problem is having you look at patterns when you multiply by 9. And we talked about this a little bit before and when we did our 9's facts. Okay. Just wanted to, I don't know, kind of show it to you again, see if we can discover some more patterns. 1 times 9 is 9. 2 times 9 is 18. So go ahead and write the 9's facts in your notebook. Five times 9 is 45. 6 times 9 is 54. 7 times 9 is equal to 63. 8 times 9 is equal to 72. 9 times 9 is equal to 81. Okay, so these are the 9 facts. What patterns do you guys notice? I'll give you a minute to finish copying that out.
As your first number, not your 9 obviously, but as the other number gets bigger, the tens place gets bigger and by 1. It's like you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you go backwards on the ones.
So yeah, the tens place gets bigger or increases by 1. As the number you're multiplying by 9, as the number times 9 increases. Okay, and then you also said that the ones place decreases, right?
Yeah.
Ones place decreases by 1 as the number times 9 increases. Okay, great. What other patterns do we notice?
This is kind of on that same note, but the numbers like flip after 45, or you know, when you get 5 times 9, and then after that, they kind of flip.
Okay, great. 54, 63. Okay, great. Any other patterns? Maybe some patterns with the problem and the answer. So the factors compared to the products. We did a little bit by increases and decreases. What about the numbers themselves?
Every single one of the products adds up to 9.
Okay. Okay, so the sum of the digits in the products is 9. That's pretty neat. Okay, great. So let's take a look. Is it a coincidence that this 4 right here and compared to this 3 is 1 less? So that the tens place is 1 less than the number times 9, is that a coincidence? For the 4 times 9?
No, because you're doing 1 minus 10.
Right. So I'm doing the 1 minus 10. Good. So it's not a coincidence because it happens on all of the number facts, right?
Yeah.
All the number facts has the tens digit, one number less than the number you're multiplying by 9. Is there a connection between the ones digit and the number you're multiplying by 9? Take a look at a couple of these here. Is there a pattern there?
It's 1 away from 10. So like 1 and 9. 9 is 1 away from 10. 8 is 2 away from 10. 7 is 3 away from 10.
Right, what do we call that? We talked about it when we were doing addition, where it's just whatever you need to get up to 10. You have a name for that. So this is all the way back from addition, so it's a long time ago.
It's the tens complement.
Right. Okay, so the two new ones that I pointed out, in addition to whatever else you guys have seen, which is good, is that the tens place is 1 less than the number times 9. The ones digit is the tens complement of the number times 9. Okay. So there's one pattern, this pattern with all of those things that you guys have said can help you or help students calculate or find the answer to something times 9. It's good to know a lot of ways to think about this because your favorite way might not work for some people. And you want me to think about other ways too. Okay, so the ones digit is the tens complement.
When I was in elementary school, they taught us the finger trick. And so those last two make a lot of sense because like when you have 10 fingers and you're taking one of them away to make that number.
Mm-hmm. That's right. And that's actually a homework problem. So that's why we're going over this. The homework problem has you take these patterns and has you connect it to the fingers method and explain why the fingers method works using these patterns. Okay? So that'll be an exercise for you to do. Great thoughts though. Okay, so a couple other things for mental math. They have some word problems, so we like to connect to word problems. So they use the nines thing again. Nines strategy. I have a couple of those. Okay. So for an example, Susan wanted to wrap 9 presents. She knew that each product required 16 inches of ribbon, each present. how much ribbon would she need to buy? Okay, can somebody guide me through the answer to this problem? How do I solve this one? Susan wanted to wrap 9 presents. She knew that each present required 16 inches of ribbon. How much ribbon does she need to buy?
You would do 9 times 16.
Right, 9 times 16. So tell us how you calculate that. And 16 inches. Let's keep our units throughout. Just for fun, or you can make sure that your units are at the end.
So I would do 9 times 1 times 10. And
Okay.
then
Let's do our 10 minus 1 thing to practice.
Okay.
Wait, did you say that or you say something else?
Yeah, I said 9 times 1 times 10. It's like
9 times 1 plus 9 times 1 times 10.
so you do 9 times 1 is 9, and then so like instead of leaving it at the 10, like the 1's place is the 10, you just add it back in with the times 10. And then I would do 9 times 6 and then add them together.
Oh, okay, yeah. So you're doing 9 times, okay, so let me do that then. So what she did was 9 times 10 plus 6. 9 times 10 plus 9 times 6. And 90 plus 54. And then what did you do?
I did the 9 and or added the 90 and the 54 and got 144
Okay. Good.
inches.
Excellent. So we can do, or we can do 9 times 16 inches with our 10 minus 1 thing. Okay, 144, does that seem familiar as an answer to some problem?
Yes, it equals 12 feet.
Yeah, so our 12 times 12. Okay, so I'm going to get to feet. So you have 12 inches, 12 groups of 12 inches. So 12 times 12 is also equal to 144. And so how is this connected here? Let's make a connection between 9 times 16 and 12 times 12. How are those connected? They both equal the same answer, so they might, yeah, so how they're connected, there's gotta be some connection there.
Well, I tried to see if like 9 plus 3 and 16 minus 3 was 12, but it wasn't.
Okay. Any
To
other?
see if the numbers were somehow similar if you did the same operation on them.
Yeah, so if you, yeah.
It doesn't work.
Okay, so this is just a little side note because I thought it was fun. 9 is equal to 3 times 3, and 12 is equal to No, sorry, 16 is equal to 4 times 4. Right? So 9 times 16 is equal to 3 times 3 times 4 times 4. Oops, I skipped that. 3 times 3, yeah, that's right. And if I use the commutative property, then I can make it easier to do 3 times 4 times 3 times 4. And that's 12 times 12. And that also equals 144. So it's another way to do the mental math on 9 times 16. Break them up into factors, little numbers, and then switch them around to make them easier. Okay. So it's kind of like an introduction to our mental math, the last part of our lesson. This is just mental math in general. Okay, let's do 50 times 14 times 2. Okay, mental math. Mental math, so the order of operations says to do the first two numbers and then multiply the third one, left to right. But with some places, like if it's all multiplication, all addition, then we can use some properties of arithmetic to switch it around to make it easier. Okay. How do I make this one easier? Using mental math.
Start by doing 50 times 2.
Wait, can I do that?
Yes. Is it
Are you sure? Because the 50 and 14 I have to do first, right?
No.
No? Okay.
No.
So then what
Unit property says that you can switch them around.
Yes, you can. Excellent. Okay, so I'm going to switch these right here. So that I can do 50 times 2. Much easier to do. Okay. That's 100 times 14. 1400. Okay, excellent. And here's another one. We'll do a number of them here. 56 times 20 times 5. Okay. Notice that I'm writing the problem on one side, setting it equal to my first step, and doing my subsequent steps below. Okay, so I want you to do that on your homework to keep it straight. So even though I'm doing all this in my head, I need to show in my work, homework, and tests that what steps I'm taking. Okay, what would I do first on this one? 56 times 20? Order of operations.
20 times 5.
Wait, can I multiply the second two numbers before the first two? Okay, what property says that?
Associative.
Okay, make a note of the properties. So a commutative property for this first one. And the associative property says that I normally start here with, let me just write that out. Oops. Normally I start here with parentheses here. But what you're telling me is that I can start with these ones. Okay? That is the associative property. Much easier to multiply 20 times 5 first. So you have 56 times 100, you get 5600, okay? Great job. Next one is 56 times 11. $56 times 11. Now on this one, we won't use commutative. Okay, go ahead. Yeah,
Didn't you say there was like an 11's trick because if with singles they repeat, but with doubles they repeat with a 0 in the middle?
well, there's an 11's trick. Yeah, the 11's trick was to take the 5 and the 6, add them up. 5 plus 6 is equal to 11. Okay, now since there's doubles, you put the 11, this 1 with the 5, and so it's got to be 6, and then the 1, and then the 6 there. Okay, so that's the 11's trick, but we're going to use a property of math, though. 11 is close to what number? Let me give you a clue there. 10. How can we put in the 10? 10 multiplying by 10 is easy.
So you break it up into 10 plus 1.
Good.
And then you do the distributive property.
Yeah, that's the distributive property. Where's my, oh, there it is. Distributive property really helps with multiplication. So 560 plus 56. How can I add those two together?
I did it 40 plus 16 so I could get to an even 600.
Yeah, split this up into 40 plus 16. So I'll get 600 plus 16, which is equal to 616. So I'm going to put this in blue since I'm doing it like. Okay. Good.
What property is that? Sorry, I can see the abbreviation, but I.
Oh, distributive property.
Okay.
The next one, 56. No. Okay, let's do 98 times 6. Okay, mental math. How can we do this one?
Could you divide it by 2? Because 2 is easier to multiply and then multiply it by 3.
Okay, good. Divide what by 2?
The 98. Because you break 6 into 2 times 3. Kind of like when you do the 5 with an even number, where you split the number in half and then multiply it by 5. That you're splitting it in half.
So you're doing 98 divided by 2 times, you have to be, so if you divide the 9, okay, so divide the 6 divided by 2, and then you have to multiply the 98 by 2. Or you can divide the 98 by 2 and multiply the 6 by 2. So one is divided by 2, one's multiplied by 2. So which one did you want?
Multiply by 2.
For which one?
98.
98 times 2 is what?
Or sorry, I meant divide the 98 by 2.
Okay, 98 divided by 2 is what?
$56.
Yeah, 2 into 9 goes 4 times though. And
it's 18.
Yeah, 49.
49.
Yeah, 49. So I have the 98 multiplied by 12 because the 6 has to be multiplied by 2. Now, is that easier? It's a good thought because it works with 5s pretty well. You could double the 98 and then divide the 6 by 2, which is the other way that we're thinking. So 98 times 2 is going to be 196. See, because 98 is almost 100. And so 100 times 2 is 200. But the difference will be 4, or 2 times 2, which is 4. Okay, then I can do that. Half, double the 98 and half the 3, 6 to 3. So is that easier? Maybe a little bit, but there's easier ways. 98 is close to what number?
5.
I mean,
100.
100, yeah. Okay, so if we do this and distribute here, And then we have 100 times 6 minus 2 times 6. And that's the distributive property. Okay. And then we have 600 minus 12. 600 minus 10 is 590, 588. Okay. All right, so we're at time. I have a couple more in the lesson notes that you can look at. And let me know if you have any questions on the homework. Have a great weekend, everyone.
Thank
So no school.
You're welcome.
Do
Till Friday.
we still have homework on Friday?
Nope, no lesson, no school, no homework.
All right, awesome.
This
Well,
homework we do on Monday.
you have a good 4th. Thank you.
Yep, you too.
Bye-bye.